Okay, this is the last part of Chapter 9, 9.6, solving similar triangle problems before you get to the review and to the practice test. Okay, so let's try these. What do we have? We've got two lines that cross each other. Okay, so what is the measure of each angle? Well, we know that this angle here is the same as that angle there. Okay, so that means that AEC is the same as BED. So AEC has got to be 40 degrees as well. CEB is a straight line, so that's 180 degrees. Okay. CED, well, we know that this is a 180 degree straight line. If that's 40, this has to be, angle E here has to be 180 degrees minus 40, okay, which is equal to 140 degrees. And AEB, this one here, because it's opposite there, it's also equal to 140 degrees. So very simple to do something like that. Okay, Marla is using this diagram to build a support for the top of a swing. The only angle marked on the diagram is the right angle. How can she determine what angles to use for the cross pieces? That's angle CDE and DEC without measuring the angles in the diagram. Well, it's very important to know we've got two other pieces of information in here. We know that this line AB is parallel to this line segment ED. We know that this is an isosceles triangle because this little line here means that this side and this side are the same, okay, which means that this angle here and this angle here are also the same, okay? So let's use that information to go and figure out our angles. So which angle in triangle DEC is equal to 90? Okay? We know that DCE is equal to 90 because it's opposite ACB. So we know that DCE is opposite here. This is 90. That means that this one here has to be 90 as well. Okay? And if that's 90, that means that this one here has to be 90 and this one here also has to be 90. Okay? Number 2. Which angles in triangle ABC correspond to CDE and DEC. Okay, well, there's angle CDE, angle CDE corresponds to angle CAB. This angle corresponds to that angle, okay? So that's CAB. And DEC, this one, DEC, this angle here corresponds to CBA, corresponds to that angle there, so that's CBA. Okay, because we have two parallel lines here cut by transversal. That means that this angle corresponds to this angle, and that this angle here corresponds to that angle. So that means that if these ones here are the same as these ones here, because we know that these two are equal, that means that this angle, this angle, this angle, and this angle are all the same. How do you know triangle ABC is similar to DEC? Because the angles are the same. And how do I know the angles are the same? Because I have line segment AB is parallel to line segment ED, and they're cut by a transversal. And from the previous chapters, we know that if we have two parallel lines cut by a transversal, then we know which angles are the same and which angles are equal to each other. How do you know that angle ABC is equal to CAB? Well, triangle ABC is an isosceles triangle with two equal sides. The angles opposite equal sides are equal to each other. So that means that angle ABC is equal to angle CAB. So what are the measures for ABC and CAB? Well, the sum of all angles in a triangle is 180 degrees. BCA is equal to 90 degrees, so that means that triangle ABC plus triangle CAB equals 90 degrees. That means ABC is equal to CAB, so each angle measures 45 degrees. Okay? What angle measures should Marley use for CDE and DEC? Well, CDE and DEC correspond to angles CAB, if you look up at the diagram, and angle CBA. Kind of hard to keep track with all these different letters. So Marley should use 45 degree angles. Okay, everything is a 45 degree. Okay? You can go ahead and do the other example on the other page. It's not hard to do. It's just keep all your angles together. Okay, keep all your triangles together and you shouldn't have a problem. Just remember the rules for lines that are parallel cut by transversals, okay, for similar angles, okay?